Du lyssnar på Fasciaguiden, en podcast om kroppen, om ny forskning och om en förändrad syn på hälsa, värk och smärta. Jag heter Axel och du ska snart få höra en intervju med professor Neil Theise. Och medverkande i det här avsnittet är också Hans och Per Johansson, och du kommer upptäcka någonting intressant, och det är att Per Johansson sitter tyst i nästan en timme därför att det Neil Theise har att berätta om, ja, vi varit väldigt tagna. Därför att det är ett samtal inte bara om hans forskning kring fascia som ett system eller hans erfarenhet som leverpatolog, utan den större förklaringen till hur vi egentligen förstår världen rent vetenskapligt och vad som behöver förändras i vårt sätt att förhålla oss till människan, naturen, människan som ett system, kroppen som ett system och planeten som ett enda levande ekosystem. Otroligt intressant intervju med Neil Theise, och vi kunde ha pratat på i flera timmar, så det känns skönt att veta att han snart kommer komma till Uppsala och träffa oss på Swedish Fascia Convention, därför att han har mycket att säga i de här ämnena. Så trevlig lyssning. Welcome to the Fascia Guide. My name is Axel and I'm here today with Per Johansson, Hans and our special guest Neil Theise. Right? It's Theise, right? Everyone says
Depends
Theise,
where you are. Theise. Yeah. Theise is the actual German, so.
Yeah. And everyone calls me Alex, so I understand the frustration around that. So we were able to put together this quick talk right in your move from the US to Lisbon in Portugal. And as you stated, you are in a house with no AC. It's warm. You can't open a window because of flies, and you only have a bed as a furniture. Yes. So first of all, how are you?
I'm terrific. It's an adjustment. We've only been here in our apartment 9 days, and impermanence. But it's also quite energizing. It was my 66th birthday yesterday, and at 66 to be throwing everything up in the air and starting over is exciting. My husband and I are really, energized by it.
You look,
and we love Lisbon, so Lisboa.
Yeah. So. You look excited, so.
Oh, good. Because I'm here with you.
Yeah.
Where is the furniture?
We just found out that it's still in a warehouse in New Jersey because the proper paperwork from Portugal had not been delivered. And so we were here for 2 weeks before we could get the electricity turned on. So this is what we're learning in Portugal, is that everything you want will happen. You just can't determine when or how. Because everything has worked out. We've been at this for 4 months, the move, making the decision and moving and finding a home and everything. Mm-hmm. But lessons in patience.
Yeah.
Also good lessons to learn when you're in your 60s. Finally.
Definitely. So I'm really I've been looking forward to this conversation for a long time, because I think the four of us have a lot of different ideas to discuss. I think we will have a lot of fun. I feel it already. But in 2 weeks' time, kind of exactly 2 weeks' time, you will be speaking at the Swedish Fascia Convention, The Living Body, in Uppsala in Sweden. Why did you say yes to this convention?
I rarely say no. If people want to have conversation, why not have the conversation if I can afford the time or the money if it's required for me to go somewhere? I'm always up for it. Yeah.
But looking at it so far, when you've had an idea of what the other speakers, the theme, the ideas, what we want to do, what do you think about it?
I'm excited because, some of the fascia people I know quite well, and we don't agree on everything. So that's always kind of fun. Mm. And though we're friends, so, disagreement amongst friends can be entertaining. But I've also been struggling for a few years now. My work, where I come into the fascia community, is through my group's definition and mapping out of the human interstitium anatomically, the work started in 2015. The paper came out in 2018. And that's how Fascia World discovered us, and how we, more importantly, discovered Fascia World, which we were not aware of. And their historic, inappropriate reasons for why the medical community has sort of divided and pushed, in part, some of, Fascia World's interests to the side, whether they be because of, tension historically between allopathic medicine and osteopathic medicine in the United States and Europe, anatomical issues, philosophical issues, etc. But we realized we're all talking about the same thing. And so I've been involved from an anatomic point of view, which is my training as a pathologist. I'm called an anatomic pathologist because that's the scale at which we're looking at clinical specimens from people, biopsies, surgical resections. But I also do this complexity work, which says that there are many ways to view the body, and each view discloses things other views conceal. But every time you reach for something you want to see that your traditional view concealed, you'll give up something else. And this notion of complementarity, no one view contains everything. The complete understanding requires different perspectives that to some extent exclude each other. We're talking about looking at the body from a both and perspective rather than
Either on.
an either or perspective. Right. And intuitively, people I speak to, and in my own heart, not so much my mind, I know these things are interconnected, but I've been struggling to find how one is the expression of the other. And I think this conference, from the conversations we've had, from the thinking I've been doing about it anyways, and particularly because of tension brought about with my group's recent proposal that the fascia is an organ system, not an organ, and can be defined in classical anatomical terms for audiences that need that. That's an important qualifier. Not for all audiences, but some audiences need an anatomical perspective. I'm starting to understand where they meet. And I think that when I said yes to this conference, I wasn't particularly seeing it as a meeting point of these ideas or a chance to explore them more deeply. But under the tension from these recent discussions and disagreements to some extent, I'm starting to see it more clearly. And so I'm excited about having the opportunity now in this conversation to explore what I mean. But also at the conference to see it in action in a community of people who are interested, see what conversations happen, what new insights arise, etc.
No, it's interesting because a lot of listeners to this conversation we're having right now are listeners of our podcast that we had in Sweden for almost 6 years now. Many episodes with me, Per and Hans. And we have talked, it's called the Fascia Guide. So it's about fascia. But we've had conversations about thoughts and feelings, how they're affecting the body, about the human drive, about why you do certain types of research, about what a body actually is, about mental health, about visceral fascia, so it's a whole, everything can be fitted into fascia in the living body if you understand how it's actually alive and how it's. We had a conversation, Per, on a live event where we talked about the body being the place where we exist. And
I think we said something like where we take place.
Where we take place, even.
Yeah.
So I would like to, because I really understand your background, because when I first saw you speak, you were a liver pathologist who just discovered fascia. That was in Berlin in 2018.
No, discovered interstitium.
Yeah. And I remember Jean-Claude Guimberteau saying in a comment afterwards, "Welcome to the fascia world. Finally, you're here." Something wonderfully arrogant and kind, as he's both arrogant and kind at the same time, which is wonderful. But then
yes, exactly.
but then I also saw a video with you explaining the human body as ants, and the self-regenerating systems. And so we would love to have a conversation with you about those things as well. I mean, the complexities of the wider scope, because you will be talking about things at the conference. You can probably listen to other conversations with you about the fascia stuff, the interstitium stuff. But it will be interesting to have a conversation about your insights and your beliefs. How can you be a liver pathologist and fascia and complexity? I mean, the book Notes of Complexity that you released, was it a year ago, or 1.5 years ago?
2 years, just
2 years ago, yeah. Feels like yesterday. But that's not the book. That's a different kind of subject, but it's also the same. So we'd love to hear more about your ideas, your journey.
So, one thing I want to respond to is your language. I mean, the fact that you've got a podcast, that you have a conference that is about fascia, and that your way of describing fascia in both hard, concrete, biomedical terms and understandings, as well as this sort of mystical, metaphysical way. And this is very common in fascia world. It's not common in other areas of allopathic medicine. And I think it's one of the exciting aspects of dealing with fascia, but it's also one of the confusing things in dealing with fascia that I think, again, I've discovered in talking to people, there are so many different ways to view fascia that seem as though that they are mutually exclusive. And so people get very territorial and, rigid if they feel they're being excluded. And again, this is in the background of the whole field being excluded. There is a real historical issue here. However, and I think this is, I'm doing a keynote at the Fascia Research Congress in August in New Orleans, that I'm going to try and help people relax into the need for these different perspectives and to understand that they're not mutually exclusive. And that comes from the complexity standpoint. Shall I dive in with the complexity view?
Yeah.
Try and do it.
Yeah, why not?
And then we can see how it applies in different ways. So I got into complexity theory because I was doing adult stem cell research around the turn of the millennium. I had a series of papers with my colleagues where we were exploring how cells from the human and the animal bone marrow would circulate through the body and become liver or lung or kidney or heart, etc. And there were other groups at the time that were doing the same thing. Ours was the first group in 2001 that actually showed that at the single cell level, it's not that the bone marrow contained stem cells for all these other tissues and organs. It's that a bone marrow stem cell itself, a hematopoietic stem cell that could give rise to all the elements of the blood, could also do all these other things. And so this was called cell plasticity, that cells were not restricted by the time you got to adulthood into the organ they could be part of. They could cross over. This was very controversial. It remains controversial, mostly because of American politics more than the science. For those of you who were adults and aware of the junction between American politics and American science, George Bush gave an address to the nation saying we can do everything we need to do with adult stem cells so we don't have to do embryonic stem cell research, and therefore we don't have to kill embryos. This was all about the American anti-abortion politics. We don't have to kill human embryos to get stem cells. Adult cells can do everything. And that's in response to my group's single cell plasticity paper, which was distressing to us that that's the use it had been, to which it had been put. Because of that, I wound up in a collaborative project with an artist named Jane Prophet in the UK. And it was funded by the Wellcome Trust, organized by a mutual friend of ours, basically so we could meet each other. He just wanted us to meet. To have an artist and a scientist talk to each other and record the conversation so we could see how cross-disciplinary conversations could happen, in the hopes that something creative would come of it. We might have failed, but it turned out it was a very fruitful conversation that led to lots of different projects. But in it, I was talking about how I viewed stem cells moving around the body. And Jane, who was involved with her own art piece called Technosphere, which turned out unexpectedly for her and her collaborator to be an early example, but very vivid example of artificial life forms arising within a virtual computer system. She said to me, what you're describing is what people in artificial life and complexity theory talk about, how ant colonies form and how slime molds form. As you know, they can either function as a body with many cells, or they can disaggregate and disappear. Where's the slime mold? The ant colony, is it the ants or is it the colony? And so we started exploring the human body as a complex system, which it turns out had not been discussed in great detail by complexity theorists. But because I'm a pathologist and I spend my time looking at the human body at the tissue level, and therefore at the cellular level, I was prepared to do that. And Jane, with her fresh ear, was able to see the connection. So we started talking about how cells move around the body like ants move around a colony, and eventually wrote up a perspective that, on the one hand, the body is a unitary thing. Organs are themselves unitary things that are parts of that larger body whole, like a car has parts or a clock has parts, from the simple standard Western mechanistic point of view. But you can also think of it in terms of the cells self-organizing into these larger scale parts. And what that leads to, and for that to happen, cells need to fulfill all the criteria of any complex system. And basically, complexity is a computational mathematical way to describe living things at every scale. It's related to chaos theory. Fractal geometries plays a role. And we defined what there are basically four ways that ants interact with each other to create a colony, or humans interact with each other to create a city, a neighborhood, an economy, a culture. That cells do all this sort of stuff. And so you could think of a city being a city as a thing, which can be understood as a unitary thing, or you can understand it as complex interactions between humans, and out of the way they interact with each other according to the rules of complexity theory, self-organize into this larger scale thing of a city. But the human bodies themselves appear like things, but they're also flocks or communities of cells. You can think of it in terms of, if you've seen murmurations of starlings, this is one of the most famous examples people are familiar with. You may hear a sound above you, and you look up and you see this large shape. And your first thought, if you're not prepared for it, is, why is there this giant balloon or spaceship hovering over the land? And then you'll have that moment of recognition. Oh, it's not a thing. It's not a balloon. It's not a ship. It's a flock of birds. Well, the same way, if you go in, it's a matter of perspective and scale. If you go in close enough to the bird, the way I'm used to doing as a pathologist, going in close to human tissues, the bird itself dissolves as a thing into a phenomenon, a flock of cells. And so whether something appears to be a thing or a phenomenon arising from interactions of smaller things depends how close in you are. What's your perspective? What level of scale are you making the observations? So now this is starting to make bodies sort of less concrete than we usually think of them. When we're doing anatomic dissections of human bodies, we're taking this dead object and we're cutting it apart to find the pieces, the way you take a clock apart to examine how a clock works. But that's a dead thing when you do anatomy. It's not a living thing. It doesn't express itself in the same way across these different scales. It can't be described as a complex system anymore because it's dead. It's not alive. So this introduced this idea, and that as it further developed with another colleague of mine, Minas Kafatos, who's a quantum physicist and cosmologist, we could start to ask the questions. And there is a Buddhist pathway from this if we want to get into the metaphysical, but I'm not going to go there yet unless you ask me. But in the quantum physics, in the physics realm, are cells a unitary thing, or does it, like the body at a different level of scale, dissolve into interactions of smaller things? And of course it does. It's molecules floating in water. And part of the one of the rules of complexity is that the interactions between objects has to have a low level of randomness in the system. Too much randomness and you don't get self into organization into a recognizable structure. Too little, the organization can't change if the environment around it changes. And so you need a little bit of unpredictability in the way the interactions happen. And that's what allows living things to explore new modes of being, to adapt to a changing environment. This is one of the essential things, what makes something alive. And molecules floating in water, but at body temperature, it's just the right amount of jostling by the water molecules. I'm sorry, I'm going to say Fahrenheit, 98.6 degrees. What's normal temperature for a human
37
body?
Celsius. 37 Celsius.
37 Celsius. Maybe this will help me remember. Oh God, I'm so burdened by my American background.
You're in Europe now.
I know, and I'm actually a European. I have a passport. This isn't a visa, but my parents left Europe and raised me over there. Now I've come back.
Yeah.
So, if your body temperature goes up too high with a fever, you die because in part the molecules are moving too quickly to interact in the way they should to create cells and structures of the body. If your body temperature goes down too low, you're sitting on the ice in the Arctic for some unfortunate reason, then there's not enough energy to drive the physiology of interaction. So body temperature itself, molecules floating in water at a certain kinetic energy, a certain body temperature, show you that the body is actually a fluid in which molecules are floating around. Cells have ceased to exist. And this becomes important, particularly from fascia world perspective. When we talk about Western medicine and Western biology, what we're talking about is that with the invention of the microscope, people could look at the microscopic level of tissue and saw that the body was made up of empty boxes. They couldn't see the nuclei, the mitochondria, the Golgi bodies, the endoplasmic reticulum. That took staining of tissues. When they first looked in, what they could see is cell membranes and cell walls, depending on what you were looking at. And those formed these empty boxes. And they called them cells because they'd look like the cell of a monk or the cell of a prisoner in a prison, and devoid of furniture. And if you try and take an empty box and break it into smaller pieces, you don't get smaller boxes. You just get fragments of the sides. So they said, oh, the body is made of cells. And we're going to call them cells because they look like the cells of a monk. And we're going to define living things as being made of cells, and all cells come from prior cells. And so that's cell doctrine, and that's what we mean by Western medicine and Western biology. But at the molecular level, the cells disappear. So cell doctrine doesn't function at a different level of scale. But Western perspectives prevent you from seeing that or inhibit you from seeing that. We'll come back to that. So are molecules fundamental units? No, they're just made of aggregating atoms. And atoms are just self-aggregating subatomic particles, all of which follow the rules of complexity. And when you get down to the smallest subatomic particles, it's not turtles all the way down. There's no infinite regression to smaller and smaller. When you get to the quantum realm, particles or strings or loops or fields, whatever you want to call the smallest quantum scale, the weirdest quantum scale entities, they're emerging as what one scientist called the quantum foam out of the energetic field of the background fundamental nature of existence. The vacuum is not an empty space. It is an energy-rich field. Space-time is an energy-rich field, according to quantum mechanics and relativity. And as an energy-rich field, thanks to what Einstein gave us, E equals mc squared, that energy will sometimes turn into mass. And it usually does so in matter-antimatter pairings. So you'll have two little mass-like objects, whether they're loops or strings or whatever we want to call them. Disagreement about that, but not disagreement in the physics world about what I'm talking about now, the quantum foam. They'll self-annihilate and turn back into energy. So there's this constant simmering of energy and mass at the lowest levels of scale. But every once in a while, one of those mass-containing objects will escape from that self-annihilation and meet other similar objects, entities, things, whatever. And they'll interact and give rise to subatomic particles, which give rise to atoms, which give rise to molecules, which give rise to everything in the universe, including our physical bodies. And so the entire universe is a seamless, complex system. And all of them, everything is a part of some other whole. And every whole is in relationship with every single part. I'll finish this explanation up with a little discussion of boundaries. And I think then this gets us into the fascia questions and other interesting questions. So if what I'm saying is true, that at different perspectives, you have to perceive the living things as either objects, things that have are inherent in themselves, as opposed to a phenomenon, a process, empty of inherent existence. There's a little Buddhist tidbit for those who want to hear it. Depends on your scale of observation. So at this level of scale, my boundary is my skin. And if we're in a room together, I can reach out and your body can touch mine with a handshake, and they're separate. And we're bodies listening to other bodies, and we're all separate. At the cellular level, where are your boundaries? Well, we know that your boundary doesn't exist as just human cells. It's a microbiome involved process. Half of your cells, current estimates, are actually non-human, bacteria, maybe some viruses, mites, other things, fungi, mostly bacteria. And at that level of scale, well, you're shedding skin cells into the environment all the time. But more importantly, everything you touch, you leave some of your surface microbiome behind. I'm touching my screen now there. I've put some of my bacteria on my computer. And someone else who comes along and touches my computer picks up my microbiome. This exchange of microbiome between you and the environment and other beings that move through your environment is so efficient that within a few weeks of people moving into an apartment together, they share a single integrated microbiome. And that includes any cats or dogs they bring into the house. And so at the cellular level, where are your boundaries? It's not at the skin. It's whatever environments you move through, whatever surfaces and people and living things you come in physical contact with through your day. That's your boundary.
It's
At
interesting
the
because we had
molecular-
it's interesting because we had the same discussion a year ago, I think, about you're breathing the same air if you're in with a room with someone. So that's another process.
That's the next level of scale.
Yeah, and you also have the if I say a word, like my words are not me, but they are from me, and those can affect you. I mean, I can tell you something that makes you feel warm. I can tell you something that makes you hate me. I mean, that will have an effect on your body and your system. So it's
Right.
and then that transcends the space as well. So it's a very interesting conversation when you think about how connected everything actually is.
Right. And the thing is, so if you go down, it's easy to present people with those examples, but there's actually kind of something you could write as an equation. The smaller down in scale of observation you go, the wider the boundaries get. So at the biomolecular level, exactly what you said, I'm breathing out, the simplest example is I breathe out carbon dioxide for the plant mass of the planet. It breathes out oxygen for the non-plant biomass of the planet. And so at the molecular level, the boundary is the entire biomass of the planet. There is no separation. At the atomic level, your boundaries get even wider. There's no atom in your body that you didn't breathe, eat, or drink from the planet. So at this level of scale, we're lonely, anxious creatures who like to argue with each other, walking around on a rock we call planet Earth. But at the atomic level, we are the atomic substance of the planet, not just organic, but inorganic. Non-living stuff as well as living stuff that in 3.5 billion years has managed to self-organize into creatures that mistake themselves to be separate. And this is the Gaia hypothesis of Lynn Margulies and James Lovelock, right? That the entire Earth is a living system, a single living entity comprised of all its organic and inorganic material. That's the atomic level view. Once you're below the atomic level, you're in the quantum realm, and we know that's where there's entanglement, non-locality. There are no boundaries. This electron that I can point to as a particle here, in fact, is a field that extends out to the entire universe. And every other aspect of the universe similarly co-localizes entirely with the whole. The parts and the wholes are not separate from each other. So the smaller down in scale you go, the wider your boundaries get. So fascia. Part of the problem with fascia is that when you look under the microscope, it's primarily extracellular matrix. It's the stuff that doesn't fit cell doctrine. It's that stuff that, and modern understanding of anatomic structures is also based on cell doctrine, because if we think of the body as machines, then the parts that make the parts are the cells. And the stuff between the cells are nothing more than the glue that sticks the parts together. And so when you do an anatomic dissection, this is a common statement in fascia world, and it's true. When I was in medical school, what did we do? We pulled away the connective tissue and threw it in a bucket. Because who cares about that? We want to get at the organs, and then we want to get at the cells. And to get at cells, you digest the extracellular matrix so you can pull the cells apart so they're isolated little things. So it's discarded. That makes sense from the level of scale of cell doctrine, because it's not cells. But it is part of the living body. And what we are showing through our interstitium work and all the people in fascia world is that this extracellular matrix, the stuff outside of cells, is highly organized and highly adaptive and highly responsive physiologically, both to the internal environment and the external environment. It isn't just glue. If you digest away the cells of any organ or of any human body, there are publishers, this has been well published in the scientific literature. If you digest away the cells, what you have is what looks like a very pale, complete body. Because the form doesn't arise from the cells. The form arises from the extracellular matrix, the fascia and the interstitial fluids that organize those cells. The fascia, everywhere you look, is comprised of mostly collagen, not only collagen. There are other things like elastin fibers, fibrillins, etc. But collagen, type 3 collagen particularly, are the major thing that comprise this structure. And when we look at it under the microscope, the reason this was missed is, and it's sort of like a girdered structure, which fascia people know from, they can feel it. What Jean-Claude Guimberteau shows you is when he goes into the tissue with a microscope, inflates with air, which is a very important artifact he's introducing in that we'll come back to maybe. Because he's not looking at the normal body either. He's impacted it in a very specific way. But what he reveals is that the collagens form this very dynamic, movable network of collagens and other large biomolecules. We were injecting fluorescein dye that comes in through the fluid of the body that's passing between these structures. So the interstitial spaces between those large-scale collagen bundles, which are called fascia, we're looking at the fluid between them and saying, wait, there's an interstitium here. There are other interstitia that are outside the fascia. There are smaller ones that go smaller and smaller in scale, but they all have collagen floating in them, even if it's just single molecules. So there's this interrelationship through the body of fairly stiff, rigid biomolecules like collagen and fluid containing structures that are mainly filled with hyaluronic acid, which has a tremendous capacity as a large molecular network to hold water like a sponge. And the dynamics, the structural dynamics between these stiffer structures and these more viscous fluid structures is what brings all the cells in the body into communication with all the other cells of the entire body. But it's not a cell, it's not large. There are cells within this, but the overwhelming volume of the system is non-cellular. So you can't describe it in terms of cell doctrine. You have to describe it in terms of a different perspective, a different level of scale. And in this case, what's very useful, not the only useful way, but one that is very useful, is the molecular level of scale. It's primary biomolecules that have self-organized into these structures in water in body temperature, at normal body temperature. And so fascia reveals itself when you get beyond anatomy, when you get beyond cell structure. It's revealed as the fluid molecular interplay through the body. And every cell in the body is intimately connected to that through its own molecules. So this is the view of the body at the molecular level. And when you examine it this way, the cell disappears. In fact, when you examine it this way, the body as a thing disappears. And so you can have people who study the fascia, and now the way we're defining it in defining it as an anatomic system, giving a language for the anatomists to talk to us in fascia world who know it's not only that. Yeah. All we're doing is giving a language to bring them into the conversation. But the way we're doing is to say that there is a fascia and the fascial interstitium, which is the more watery hyaluronic acid-based fluid component within those stiffer collagen bundles. It's the fascia and the fascial interstitium as a two-phase structure that distributes throughout the entire body as a single continuous structure that allows for primary function, fascia world basic principles, tensional loading, like in tendons, when the collagen bundles, there's little water and the collagen bundles are parallel with each other, great for tensional loading. Skin, where you need shear mobility, you have a very differently organized collagen and much more interstitial fluid in the dermis and the subcutaneous tissue, even in the epidermis. So the fascia distributes through, and its interstitium distributes through the body. There are general principles that apply across all of it, but there's specific needs in every location that give it site-specific features that make it, the fascia in the abdomen is different than the fascia in the dermis, is different from the fascia of tendons and ligaments, etc. So it's a view that allows us to incorporate notions of what is a living body from different scales of perspective, and allows conversations about function and physiology along a much broader array of interests and potentially therapeutic interactions beyond what allopathic Western medicine and Western biology allow. But it's not that one is right and the other is wrong.
Yeah.
The image I use in my book of two faces in profile looking at each other, and the space between them looks like a vase. What's the complete understanding of that picture? If you say it's two faces, you've missed the vase. If you say it's the vase, you've missed the two faces. What's the understanding of light at quantum scale? Is it waves or is it particles? Depends on how you examine the light. And if you say it's one, you're missing the other. If you say it's the other, you're missing the first. And this is what I meant at the very beginning when I said, you know, it's a both and situation. It's not either or. So all these perspectives are true from their own perspectives. None of them are correct in and of themselves to the exclusion of other things.
I think it's interesting to see because we talked with Jean-Claude Gerard Pollack yesterday, and he also came from the cellular field. But to understand what's the energy, what's driving everything, and
well, the energy thing. So this is where the molecular slides into the quantum scale.
yeah,
And this is one of my favorite parts. So first off, hyaluronic acid is highly negative charged, if I remember correctly. Sometimes I get confused, but it's one.
Yes, it's negative.
That means that water can bind to it through the charged pole of the oxygen atom, you know, the structure of water, can be sticky. But biomolecules, small to large, flowing through it, if they are also charged, if they're charged positive, they can't get through. They're going to be stuck to the hyaluronic acid. Neutral and negative charged particles will zip through. In fact, negative charged particles will probably zip through more quickly. Therefore, you have flow of ions, which means you have an electrical current. So within the hyaluronic acid filled interstitial spaces, there's an electrical current, electricity. Collagen, interestingly, there's something called piezo crystals. They're forms of molecular structures that have the interesting property that if you bend them, if you move them, they generate electrical current. Or if you shoot electrical current through them, they move. An example of this in everyday terms is there's a piezo crystal inside an ultrasound machine. And when you turn on the electrical current of the ultrasound machine and shoot it through the crystal then turns that electricity into kinetic movement, vibrating, and that creates the ultrasound waves. This has implications for people who use ultrasound in healing human tissues after injury, which I bet we wind up talking about that at the conference. So collagen normally is not piezoelectric, but if you stack up collagen fibers enough, it becomes piezoelectric. How thick do you have to stack them? The thickness that we find within the large scale fascia. So that means that fascia, when it moves, generates an electrical current. How strong an electrical current? My team knows it can be measured. We've worked with some people to do that. How can that affect change in the body? We're not sure yet. This is preliminary work. But now we can say the fascia and the fascial interstitium are generative of electrical current independent of the nervous system that extends throughout the body. Therefore, it is generating an electromagnetic field at the quantum scale. That means it's coextensive with all the electromagnetic fields of the universe. And our bodies are in communication bioelectromagnetically with all other systems.
Mm.
There's a classic study. I think I found the original paper. It's not a terrific paper. I don't know that anyone has ever replicated it. But there is this discussion from this one paper from 20 years ago that if you take a living beating heart, let's say from a mouse, and put it in an electrical field, the beating of that heart will entrain to the pulsing of the electromagnetic field. Now, hearts generate an electromagnetic field. So you take two hearts, living hearts, and put them near each other. They are both generating electromagnetic fields that are going to entrain each other to the way they beat. How sensitive are they? What's said is that within 10 or 12 feet, one heart can generate and entrain to another heart. So what happens when two people are living together for 40 years, sleeping together 6, 8 hours a night with their hearts within 1 foot of each other? Are you two or are you one?
Mhm.
At the electromagnetic level, you're a single living system. You're not two separate systems.
We tried to do with a guy we met. We tried to do needles. If you put an acupuncture needle in one person, it will affect the other one. If you're it's like me and my wife did it. It was the same. So you can took the needle in me or my wife. It was the same effect.
And if you look at the work of Mike Levin, who studies living bodies as electromagnetic systems, you can affect the electromagnetic system in one limb and you get the effect in the opposite limb. And this is very hard. I mean, he very well may win a Nobel Prize for the stuff he's doing, but the non-locality of effects on the body at scales beyond or beneath, depending on how you look at it, the mechanical scale is profound. If you're a practitioner, a body worker of any kind, and you're coming into a room with a patient, you are already merging into a single system with that patient as you come down the hall and enter the room, let alone when you begin to approach the body from a mechanical, physical perspective.
So, what we have discovered in that same theme is that because we have a lot of treatment clinics all around of Sweden, and we also have an extended network of therapists working with that we have trained and so on. And what's interesting is that if you create an environment of trust and you make sure that you approach your new customer with a sense of sincerity and a sense of presence, the effect of the treatment increases massively. Because of the safe space, if someone is in a safe space, they heal better, which goes towards what you're saying now with the electromagnetic capacity of the body and so on. So it's really interesting if we start taking this serious. Not the frustration, but in some ways frustration that we feel is that if you just take all these things seriously, we can really do some amazing things.
Okay, but now you're bringing us to the metaphysical.
Yeah.
Because when you're talking about your intentions, you're not talking your healing intentions, or as the person who needs some therapeutic intervention, the openness of belief. These are things in the mind. This is not electromagnetic. These are things in consciousness. These are experiences in consciousness. And so another way in which our modern culture has locked us into what I would say is an incorrect, incomplete, and unfavorable, unhelpful perspective is that if the universe is a machine, if living things are machines, then the mind is a product of a machine. And the amazing aspects of the mind are simply because the machine is a complex system and generating these larger scale structures that we say is the human mind. The human brain is so complex that it can actually, as a complex system, generate larger scale structures, which is human consciousness. The problem with that, number one is the famous hard problem of consciousness, that no matter how much people investigate functional physiology, structure, anatomy of the brain. Tens of thousands of papers, maybe hundreds of thousands now. I should look up the number. Cognitive neuroscience has never been able to show how the brain creates mind. There's nothing that explains that. But human experiences show a very different perspective. If you are an adept meditator in just about any tradition, when you dive into your mind to examine your own mind, and this is something this is the whole second half of my book. There are a couple of things that are happening here. Number one, empirical science can no longer apply. Empirical science, modern science, says that a scientific investigator needs to be separate from the object they're studying, in which case you can have objective data that comes out from the experiment you perform on the object, so the subject can interpret it. This is already a problem in quantum scale events. We know that. The classical Copenhagen interpretation of quantum physics is that conscious observation is what determines the outcome, what is seen, the nature of reality at the quantum scale. There are people who will argue with this, but they argue with it because they're made uncomfortable, like Einstein was made uncomfortable, but no, the world is a machine. But people will tell me, well, you're a liver pathologist, you don't understand quantum physics. Well, Minas Kafatos, he's a real quantum physicist, my collaborator in this, so he checks me out on this. And I'm happy to stand with Niels Bohr, Werner Heisenberg, Wolfgang Pauli, Max Planck. Okay, that's my team. And they say consciousness comes first. Planck said it literally. Consciousness comes first. There is no way to explain matter and energy in which it isn't arising from consciousness and being defined and created by consciousness, not the reverse. So in that case, the model I present in my book of the universe as a complex system isn't simply down to the scale of space-time and the quantum foam. Underneath that, around that, above that, whatever perspective you want, is a universal consciousness. And the function of our brains is not to create your mind, but to sample that universal consciousness. The radio samples infinite radio waves. And if you tune it just right, it pulls out the Beatles song. But the mind of a bee is going to pull out bee experience the way a differently tuned radio is going to pull classical music from a classical music station. Brains are transducers. They're sampling the larger, infinite, beyond infinite array of possibilities of the larger mind, the source, the ground of being, whatever mystical words you want to apply from your culture, God, that can work too, and transducing it into your personal human small mind, your own personal human experience. And when you're dying, what you're doing is not losing that mind because there's no body to create it. You're simply losing the fine tuning. When you mistune, when a radio misfunctions and you get static, you're not getting less information. You're getting more information. So you can't hear the music within that cloud of information. I think when you die, you start to lose your human mind that's specific to you and perceive the larger consciousness. This is my next book, actually. Talking about this stuff through the lens of my mother's last 6 years, when she lost her short-term memory and started talking to dead people, had end-of-life visions, started traveling on the astral plane, meeting other people I knew who could travel the astral plane and reporting back to me. So we have to include consciousness, mind in this. And so when you're talking about the intentions of the healer, the intentions, the beliefs of the person receiving some sort of practice, it's happening at that level of scale. A level of scale that can't be defined by distance or time. It's not infinite. It's not eternal, because time and space don't exist at that level. And all things are completely intimate and expressions of exactly the same source, the same large M mind, big C consciousness.
That's think it was interesting when I talk about infinite and the universe. When I was in contact with the guys who was in the electric universe, and the universe actually looks like fascia.
So, yeah, but this is, to me, sure, but everything looks like everything because everything is fractal.
Yeah.
It is the nature of fractal systems, and chaotic systems and fractals extend just as complex systems do, define the universe. The primary feature of fractals that they are self-similar across scales. So you look at a tree trunk, and then it branches into two limbs, and they branch into branches, and they branch into branches. If you go in close enough, each one looks like a tiny little trunk, smaller and smaller and smaller. The branching and structures are the same across scales. The structure of the universe is the same across scales. Complex systems exist mathematically where perfect order meets chaotic fractal systems. And so complex systems are by their nature self-similar across scales. And so to say that the universe looks like fascia, well, the universe looks like the universe at every scale, and fascia is one of the reflections of that scale. It's not that fascia is so remarkable that it reflects the structure of the universe.
No.
It's that the universe is so remarkable that you see it in every smallest detail of itself. Each whole, each part reflects and contains the entire whole. But you have to decide, do I want to look at the whole or do I want to look at the parts?
Yeah. So, Hans, you said you had to leave at 11:30 our time. I think we need to continue this discussion a little bit longer, so you can just
Sorry.
turn it down and go, because Per, I've listened to you for 200 hours of podcasts as a historian of science and ideas, and you've talked about Aristotle, Pythagoras, the Stoics, Heraclitus, Plato, fire, water, drive, the earth. I mean, scrolling to like different subjects you have been covering in your podcast, the ancient Egypt, Greek mythology, the Gnostics, Paulus. You made a deep dive of the Bible. This must be really interesting for you to listen to, and you haven't said anything through the whole hour. What are your thoughts so far?
I have very little to add to what Neil has said, because I find myself epistemologically, ontologically, and metaphysically in complete agreement with everything. So, which is a very good basis for some adventurous conversations, I think. I have one more specific question regarding fascia and the role of fascia in the living body, and perhaps I can put it like this: if you understand the fascia as a complex system, including the interstitial fluid, then if you understand it as a complex system interpenetrating other complex systems in the body, would it be in the right direction to say that the fascia, in fact, is what is one system, I should say, but perhaps a more crucial system than we've understood earlier. The fascia is a system that actively links what goes on in the organism as a whole with what goes on in individual cells and groups of cells.
Yes, but again, I'm careful to try and I'm going to use some hyperbole for what I think fascia is and can do.
Yeah, good.
But at the same time, I'm going to ask to be careful about guarding against the hubris that arises from being the suppressed younger brother who has to respond, younger sibling who has to respond by saying, but I'm the important one. there are things about fascia that can accomplish and do and serve functions in the human body that are not served by other systems. Well, of course not. Every system performs a crucial function.
Certainly.
Fascia is not going to do very well without a beating heart.
Of course. That's not really my point. But
no, I know, but I'm just, but I'm sensitive. I've become sensitive to when people in fascia world will make the kind of statement that you just made. This is, just sort of a side note, but I'm finding this seems to be part of my function in this community at this particular moment. What you suggest about fascia sounds astonishingly important. And it is. But at the same time, we have to be cautious that doesn't make it more important or more astonishing than my favorite organ, the liver. I'm going to say, as a liver person, fascia is pretty good, but the liver is pretty great. So we'll just say that. But what I think the fascia does, the definition we give, because contemporary anatomy requires a primary function for an organ. The heart pumps blood. We know it does many other things, but it requires one thing. So we chose the simplest mechanical aspect of fascia for that definition: tensional loading and shear mobility. But it's also a communication network, as we've already described in bits and pieces. It's a communication network at the electromagnetic level. It's a communication network at the small molecule level. Look at glucose monitoring, interstitial fluid monitoring, glucose, whatever the things are called. My husband's a type 1 diabetic. He lives on the small scale sampling of glucose as it flows through his insulin, through his interstitial fluid, to monitor the entire body. So there's communication at the small molecular level. There's communication at the large molecular level. Cytokines and growth factors are probably being actively modulated by the size and charge structures of the hyaluronic acid through which they're passing. Cells move through here. Tumor cells in disease, microbiome signaling is probably happening through these systems. Infection certainly spreads through these systems. And then there's the large scale mechanical stuff going on of just like, that an orthopedist deals with. The body has body-wide communication networks already. It has the nervous system and it has the cardiovascular system. But neither of those communicates at every level of scale. Only the fascia and its interstitium serve as a communication network across every level of scale.
That's one reason for my question. But beneath this more specific question lies the problem of, as you have yourself described, by means of complexity theory, you can describe mathematically the self-similarity across scales. But if I focus and try to understand, or in some way, at least intuitively, but I think it could be done much more scientifically as well. If I try to grasp the actual living body and think in terms of perspectives, I can say, as you did, that depending on what scale you focus on, you get a different perspective. And
a different body as a result.
Yes, exactly. Yeah. And you can also learn how to shift perspective without getting confused and without thinking in terms of contradictions epistemologically. Yeah. So I'm completely in line with that. The problem I see, which I think quite few people really address, and this is one reason why I became interested in fascia and asked you the questions I did just now. I think we need a much more thorough, detailed understanding of these kinds of systems which function as a kind of, how shall I put it, connectors between levels in the living organism.
Yeah.
Which fascia is one, as you said, there are others. And I think what is not studied enough and not comprehended enough is actually those kinds of functions.
I completely agree with you.
How would you say which possibilities do you see scientifically in addressing that kind of question? Because it means that you cannot conduct research in those terms within the existing academic structures very easily.
Yeah.
To start with.
This is kind of what I meant when I said that the Western perspective, whatever the idea that the dominant metaphor for the universe and for living things is machines, that parts give rise to wholes in a predictable fashion, that things exist in hierarchies rather than holarchies, a term coined by Arthur Koestler. A holarchy is comprised of holons, which are parts that are, each part is equivalent to the whole. And what can you possibly mean by that? But we've gotten comfortable thinking what we mean by that at the quantum level, where we have non-locality and entanglement. What we're not comfortable with is understanding that that exists at levels of scale up to the everyday. The word we used for this, as I said earlier, was complementarity. Niels Bohr applied the term complementarity to light and the duality of light being both waves or particles, depending on how you experiment or examine it. He felt that complementarity was a universal principle across all scales, not just a quantum level phenomenon. He believed this so strongly that he used the yin-yang symbol as a representation of the principle of complementarity, put it in his coat of arms, and actually it's on his tombstone where he's buried. It's that fundamental. But the modern mind in our culture is not prepared to understand complementarities.
Especially not as it's not a static concept.
Right. No. And, I could also bring in Lord Alfred Whitehead. Everything is process. There is no thing in the world. It's all just process.
Yes.
Our funding systems are built on classical Western medicine and Western biology. Biomedical funding systems are built on cell doctrine and anatomy. As long as you reify those as special, you're going to miss stuff.
But this would be part of your lecture, Per, that you would hold on the conference.
Yes, some of I haven't prepared any lecture yet, so in one way or another, probably.
That we have efforts in this direction in the US. However, I have a feeling these are degrading at a rapid rate. NIH's Integrative and Complementary Medicine Division, run by Hélène Langevin, who's well known in the fascia world, studies acupuncture in part herself. I don't know what the state of her institute is at this point, but she's definitely, and she was an important advisor on this whole
article,
fascia as a system thing. She has been consequential in moving within her division funding systems to account for other kinds of things like the body as a bioelectromagnetic field. People do slip in research into more traditional funding mechanisms to study this, but they have to place it in those terms, which makes it tricky. It requires a cultural shift in what we understand. And if we want to include consciousness in this, and I think we have to.
Yes, I agree.
And then the research, here I'm going to sound like, to some people, like I'm a lunatic, but that's why I have a 4.0 for my book on Goodreads out of 5 points, because 20% of the people think I'm an idiot who completely doesn't understand quantum physics. So there's 20% of the people who strongly disagree with this. But the other day I was on a panel with some yet more senior people who talk about consciousness. One of whom is a long-term meditator, and yet a materialist, which I really don't understand. And one is not a meditator, and functions in that larger community as a neutral mediator between, to facilitate conversations, though I think he's pretty much of a materialist. And two other women, both physicians, who sort of agree with me on this stuff, in front of an audience of about 80 or 90 people in New York. I'd say the average age of the audience was around 40, meaning decades younger than the average age of the people on the panel, particularly the guys, who were mansplaining a lot. That was its own problem. And I was getting pushback pretty strongly from the materialist members of the panel. And I tend to avoid being put in this kind of position. I'm not a good debater, and I just don't really see the point, and I don't enjoy it, probably because I'm not good at it. But then I was watching the audience, and I realized I didn't have to convince anybody in this room.
I don't think it's a matter of debate, really. It's about
no. And the younger generation,
you have the insight or not. Either you have,
right.
either you're directed in a proper direction, so to speak, in your life or not.
Yeah, and I think people if I may be overly projective, I think you and I are probably substantively older than Axel is.
Yes.
And people in Axel's generation don't need to be convinced of this, because this is their intuition.
Yeah.
They're growing up where they've seen the culture that prizes these views as having failed. And so they're already open to, well, what are the alternatives that make more sense?
Yeah, and we also seen the world change around us.
They were nodding.
Yeah.
They were nodding along with me.
And I think a lot of my generation, and especially younger generations, because we've seen so many fundamental changes. I mean, the world has fundamentally changed in all aspects of the world in 20 years because of the internet. I mean, there are ways of living now that are completely different. So we've been witnessing that change. And then when you witness that change, you see that change can happen, and such radical change. And I think that can create hope. And I also think there's a sense of hopelessness in parts of my generation as well, because the future is not what it used to be.
Right. No, that's why we moved to Lisbon. That's a separate. The future we imagined for ourselves in New York already has ceased to exist.
But I have to, because we kind of need to wrap up. But I have two things that I intuitively wanted to bring up. The first one was when you talked about what system is the most important one, etc., not being the little brother wanting to step up and so on. Everyone knows the first Corinthians 13 that you do in weddings. About love and the power of love and everything. But I personally really like number 12.
I'm actually Jewish, so I don't know that.
Okay. No, but it's about, I just think it's such a wonderful term, because it says that the body is one, but have many members, and all the members of that body, being many, are one body.
Yeah.
But if the foot shall say, because I'm not the hand, I'm not of the body, is it therefore not of the body? And if the ear shall say, because I'm not the eye, I'm not of the body, is it therefore not of the body? And if the whole body were eye, where were the hearing? If the whole body were hearing, where were the smelling? And if it all was one member, where are the body? But now there are many members, yet one body. And I think that's such a beautiful way of describing how everyone is important and everything is important. We have different parts to play. It says that some are healers, some are prophets, some are apostles, some are teachers, some are working miracles, but are all doing all these things? No.
Some are liver pathologists.
Yeah, some are liver pathologists. Some are human ecologists. Some are podcasters. So I think the hierarchy of importance is a charade or a false idea.
And that's because the word hierarchy, which only humans, primates, and canines, as far as I know, really, it's not a useful way of organizing an understanding of the world.
Yeah. And then I wanted to end on something that's very practical, because that's what one of our things is, that we take these complex things or we take these cases or we take these ideas and we make it into something that you can actually do in your life, so it's actionable. What we did when we did the document The Living Body, we talked about the fundamental principles of life. For example, that all that lives has a flow. So flow is very central for life, or that the life you're leading directly affects your structure and your flow. So more flow brings you more life, basically. It's a way of the things that make you feel alive actually is good for you, body-wise as well. But then me and Per has been discussing other fundamental principles about life, for example, that by overcoming obstacles, you are stronger, you become stronger, because that's true of the immune system, that's true in nature, that's true in spirit, that's true. So I like those things that are true on many different levels. Another thing is that if you I had one, it's painful to grow. And I have a 7-month-old son at home. It's painful to grow, I can tell you. It really hurts when you get your teeth. It really hurts when you grow, and it can hurt
hurts
to
you
grow.
to watch it.
It hurts me to grow as a parent. It hurts me to realize that I have to let my kids make their own mistakes, etc. So it's painful to grow. That's also one of the fundamental principles of life. But you mentioned a long time ago in this conversation, there were principles of organization that were fundamental. Could you end by giving us one or two of those, like fundamental principles of organization that spans not only in the body but through life itself, if you can find one or two?
Rule number 2, as I put it in chapter 3 of the book, there has to be an overall balance of what are called negative feedback loops. Negative doesn't mean bad. Negative means like an air conditioner, temperature gets high, air conditioner turns on, temperature gets low, air conditioner turns off. It is the nature of living systems, of all complex systems, to oscillate through a realm. There's no static. The only static state is death. If you're alive, there's constant change within a healthy state. Positive feedback loops can come in and be helpful, such as when you have a fever because you've got an infection, and the fever drives your metabolic state to rev up your immune system to fight off the infection. But then your body temperature comes back to normal. Otherwise, you're in trouble. Back to this oscillating, homeostatic, healthy realm. This oscillation and this principle of balance between a range of healthy states is something that's true with all living systems, all complex systems. What we're looking for is not stability. We're not looking for growth. That's the problem with eternally. That's the problem with capitalism. We're looking for a healthy, oscillating state. I'm sure there's a more elegant way to put this, but my brain doesn't tilt towards elegance, I'm afraid. And the other thing is that there's a low-level randomness in the system. And what that means, Stuart Kaufman, one of the founders of complexity theory and the primary, I think, biologist who talks about complexity, he has an elegant mind. And he talks about this limited range of randomness, unpredictability in a system means that around every present moment in a living system, there's a cloud of possibilities, what he calls the adjacent possibles for what the next moment might be. It is not an infinite array, because then you would have everything's possible. This is one of the issues with the metaverse. Everything's possible. So where's the meaning? Where's the possibility for adaptation? But if there's no alternatives, then it's a machine. There's no adaptation. It's not alive. So it's an undefinable but limited array of adjacent possibles. And out of those, one will become the next moment. And we can't predict what that will be. If you knew the position of every quantum entity in the universe, you would still not know what the next moment would be, because the world is not a clock. It doesn't work like clockwork. Whatever your situation is, there are adjacent possibles that you can't even imagine that may tilt it in a direction you love or a direction you loathe. But the very next moment will hold the very next possibility and the very next possibility. So this is what keeps me, I'm no longer, I don't face political situations with the same fear or rigidity that I used to have, because I've seen enough election cycles, which are also expressions of complex systems, that you don't know where the next change will be, or how prominent that will be, or what direction it will go. You just can't know. So it makes no sense to be optimistic about what you want or pessimistic about what you hope for.
Yes.
It's simply, what's the flow of the next moment? Be in the now, and you'll see what the next moment is. The central thing my mother said to me, that's the central thing of the book I'm writing about her. She had lost her short-term memory, and she had been an anxious woman for much of her life. And I think this comes out of complexity theory, although she wouldn't have stated it that way. I said to her once, you're even smiling when you sleep. How do you stay so happy now? Because she had not been like that most of her life. And she said, well, I no longer worry about the future, and I can't remember what just happened. So all I have is the now. And when you live in the now, you're happy.
Wonderful.
Yeah, that's nice. Yeah, that's a good note to end on.
I thought so.
Yeah, thank you so much for this conversation.
Oh, sure. Thank you for having me.